Hello. We're going to cover optimization in the next three chapters, chapter 12, 13, and 14. And this week we're covering linear optimization. And so we're going to have an example here of doing a linear optimization using Microsoft Excel. So the particular context is a small manufacturing company of golf equipment and supplies, PAR Incorporated. And management has decided to move into the market for medium and high-priced golf bags. PAR's distributor has agreed to buy all the produced bags by the end of the time period. So there's several operations involved in this. And one of them is cutting and dyeing of the material. Another is sewing. And then the third is going to be finishing. And there's only a certain limited number of labor hours for each one of those skill sets to do this work. So with the cutting and dyeing, we have 630 hours, sewing 600 maximum, and finishing 708, and then inspecting and packaging 135. We also get a profit contribution of $10 from a standard bag and $9 per deluxe bag. So what we want to do is develop a mathematical model of PAR Incorporated, their problem, to determine the number of standard bags and the number of deluxe bags to produce to maximize total profit. So we go through a problem formulation process, and that's the process of translating the verbal statement of a problem into a mathematical statement or model. And we see the guidelines here for doing that. We have to understand the problem thoroughly. Then we describe the objective. In this case, obviously, it's maximizing profit, but how do we calculate profit in this particular instance? Then we have to describe each constraint. What are the constraints that we have to abide by, such as available hours, available money resources, availability of other resources, and schedule requirements, things of that nature. The next thing we do is decide or define the decision variables. And the decision variables are the variables that we are going to change to maximize the objective function while not violating any of the constraints. So in this case, it's obviously going to be the quantity of standard bags produced, and the quantity of deluxe bags produced will be our decision variables. And then we're going to write our objective function in terms of the decision variables, and likewise write our constraints in terms of the decision variables. So let's take a look at how this appears in an Excel spreadsheet. So here's our model, and let me go ahead and run calculation now and show the formulas. So this is the production time. In other words, how many hours of cutting and dyeing, sewing, finishing, and inspection and packaging for the two different types of bags. So just as an example, take 7/10 of an hour to do a standard bag to cut and dye it. It takes 1 full hour for a deluxe bag. Likewise for sewing, it takes 5/10 of an hour for the standard and 5/6 of an hour for the deluxe. Finishing, inspection, same thing. we see the profit per bag, and that, of course, is going to factor into our optimization, is $10 for a standard bag and $9 for a deluxe bag. We have hours available for each one of the operations. 630 for cutting and dyeing, 600 for sewing, and so on. These, of course, will end up being our constraints. Here's our decision variables, which are the number of bags produced. So B14, let me come, yeah, there we go. So B14 is the number of standard bags produced, and C14 is the number of deluxe bags produced. So if we do a sum product of that vector, B14 to C14, and we multiply that by the profit per bag for each one, a B9 to C9, what we get, as we see in our sum product for the profit, is the total profit. The number of bags times the profit per bag for each respective type of bag. So that's what we get with our sum product. Now, we also have constraints. And for every bag produced, we're going to be using up valuable labor hours. So just as an example, let's take a look at cutting and dyeing. So we have our sum product here, and we're going to take our same decision variables, which are B14 and C14, and multiply those by the hours for cutting and dyeing for each one of them, which is B5 and C5. So that's going to give us the hours used for each one of these. Now, hours available, we see is just going to be equal to D5. We could have put our constant constraints down here, but sometimes it's convenient to put them in a separate location so you can change them very easily. And if they're used throughout the spreadsheet, you only have to change them in one place. We do the same sum product for each one of our different operations, multiplying the hours for each one of the bags for that operation by the quantity of bags each type sold. Now, I started off with just one bag as placeholders to run through, and we can see that let me go back and get off formulas. We can see we're well below our constraints. And with one bag standard and one deluxe bag produced, our total profit is $19. So what we want to do is optimize that. And we'll use an Excel tool called the Solver to help us do that. So let's go up to Data. Then we'll go over to Solver. And in Solver, what we do is we enter in the constraints, the objective function, and the decision variables. So our objective function is B16, total profit. And we want to maximize that. So we'll set that, the next part, to max. Sometimes we'll do a minimization. Other times we'll want to say, what are our options for producing a profit of 800 or some other value. But in this particular case, we want to maximize our profits. And we're going to do that by changing the decision variables that are in cells B14 here and C14 here. So those are the quantities sold. Oftentimes, quantities are going to be our decision variables. Then we enter in our constraints by clicking Add, and then we can put in a cell range, and we can put in a relational operator, and we can put in a constraint. So in this case, we're going to put in B19 through B22 is less than or equal to C19 through C22. With that constraint in place, then we can choose a solving method. We'll use the simplex method in this particular case. Then once we selected that, we can click the Solve button. And it tells us that it found a solution. Solver found a solution. All constraints and optimality conditions are satisfied. So we'll say OK. And our total profit for this period of time, subject to the availability of labor hours in each category, the maximum profit we can make is $7,668. And we do that by producing 540 standard bags and 252 deluxe bags. Thank you.